Water is essential to life on Earth. Mapping the location of water was part of the first known landscape map from 13,000 years ago, which includes the location of a river humans may have needed to cross while hunting. Over time, maps became an important way to help people navigate their surroundings. Without modern-day tools like GPS, knowing the location of rivers and lakes helped people figure out where they were. Some of the most widely used maps in the U.S. were the topographical maps created by the USGS, the United States Geological Survey, established in 1879. The blue lines on these maps are the national standard for showing the location of water. Besides helping with navigation, maps that show water are used for environmental management, disaster planning, scientific research, and more. In the 1960s, Roger Tomlinson and others started to develop computer-based systems that allowed map information to be stored and analyzed digitally. These systems, called Geographic Information Systems, or GIS, have become increasingly powerful and popular. GIS technology is the foundation for tools like Google Maps, or any other application we use to view maps on our phones, computers, and in cars. It's become a critical technology in business, environmental protection, science, and agriculture. The USGS began converting their paper maps to digital data that could be used in GIS. The blue lines on the maps showing water are a data layer called NHD, or National Hydrography Data. Hydrography is the science of surveying and measuring physical surface water features like oceans, lakes, rivers, and streams. For the last 20 years, the Washington Department of Ecology has had a hydrography steward who served as the state coordinator of NHD with USGS. The NHD is considered the authoritative data for hydrography in Washington. All state agencies are required to use this data. As technology has improved, the inaccuracy of the NHD has become more noticeable and problematic. Now that we have higher resolution imagery and GIS data, the inaccuracy of water locations is more obvious on maps. USGS has developed a new program called 3D Hydrography Program, or 3D-HP, to remap the entire U.S. with new, more accurate methods. To do this remap, the USGS is relying on a data collection method called LIDAR. LIDAR stands for Light Detection and Ranging, and it's a method of determining the height of the Earth and things on the Earth from an airplane equipped with a laser device. While the plane is flying, the device emits thousands of pulses of infrared light and measures the amount of time it takes that laser pulse to reach the ground and then get back to the sensor. This provides a relative distance between the plane and the object the laser bounced off of. Through additional analysis, we can remove objects like buildings and trees to leave only the points identified as the ground. This creates a digital elevation model, or a DEM, of the ground. New LIDAR systems can model ground elevation very accurately, and we can use these surface models to predict how water will flow across the Earth's surface. For the first time in history, we can predict where water is flowing, even in places where we can't see it from aerial photography. This allows us to dramatically improve our ability to map the location of water. We work with contractors who have fine-tuned their models based on USGS specifications to very accurately predict where water flows. Although hydrography models are good, they aren't perfect. That's why the Washington State Hydrography Dataset Program, or WashD, works closely with local agencies and tribes to get their expertise. This can help improve the maps in areas where water doesn't always follow the model. For example, where water flows through a pipe underground or through a small ditch. The goal is to create a map of water that meets people's needs, whether it's for navigation, science, policy, or just to hang on the wall. Locating water isn't the end of this work. Linking additional details to the water is also important, and this includes information like, are there fish? How warm is the water? Are there pollutants in the water, and when were they measured? Many different organizations collect this kind of information, which helps us better understand the various components of water. By working together, we can combine all this data and make it even more useful. One great example of how additional hydrography data can be useful is in the understanding of salmon distribution. This work is a collaboration between the Northwest Indian Fisheries Commission and the Washington Department of Fish and Wildlife. They measure the distribution of salmon species in Washington streams using hydrography data and information about where the fish tend to live. But what if we want to know if there's something blocking the fish from going further up the river? The Washington Department of Transportation and the Department of Fish and Wildlife use hydrography data to measure fish blockages, which can be natural barriers like waterfalls or human-caused blockages like culverts. By combining data about fish distribution and blockages, we can determine which of these barriers are stopping salmon from moving upriver. We can also determine how much additional stream would be available to the salmon if the barrier didn't exist. Next, we can look at data from USGS, who run models to predict which streams will have enough water to run all summer and not go dry. We can then figure out which of the streams available to salmon will then have enough water for them to survive. Using this approach, we can add additional information about summer temperatures, water depth, pollutants, and more to create a more detailed picture of what water can support salmon and what factors might be limiting where they can survive. This is just one example of how bringing together hydrography data improves scientific understanding of water resources, leading to better informed environmental policies going forward. Collecting more accurate hydrography data doesn't just help fish, it also supports advancements in scientific research, navigation, policymaking, environmental protection, disaster and spill response, firefighting, and much more. The WashD program has been awarded state funding to complete this important hydrography remapping work over the next 5 years. Close collaboration with state, tribal, and federal partners is key to this effort, and by continuing to share resources and information, we can develop a more complete understanding of Washington's waterways and the place we call home. To learn more about our work improving hydrography data in Washington, visit the WashD website.